Hello dear student, myself Kanchan Vishramji Kumbalkar, Assistant Professor of Sri Shivaji College of Arts, Commerce and Science, Akola. This is my 8th lecture of Unit 4 of MSc First Year, Paper 1, Inorganic Chemistry 1, which include 2 parts. A part has been completed in a previous lectures, and from this part we are starting with the metal ligand equilibria in solution, which is a B part of Unit 4th. This is the Unit 4th A part, which has been concluded in a previous lectures. From this lectures we are dealing with the metal ligand equilibria in solution. This is the overall syllabus of the Unit 4 B part of metal ligand equilibria in solution. So let's start with the first point on this lecture. This lecture we will discuss with the stability of complexes in aqueous solution. Now the term stability can be used in a number of different ways. The statement that a complex is stable is rather loose, since several interpretations can be placed upon it. When the term stability is used, it means that the complex exists and under suitable condition it may be stored for a long time. Means, suppose you take a sodium piece and you put it into a kerosene, then it remain unreacted. Means the sodium is stable in a kerosene. But when we are talking about the complexes, it becomes quite loose. Hence, to modify a definition of stability means this term which cannot be recognized for generalized for that of the complexes. Since a complex may be quite stable to one reagent and may decompose readily in the presence of another reagent. This term may also refer to the action of heat or light on a compound. In studying the formation of complexes in a solution, there are basically 2 kinds of stability of complexes can be considered. These are, first one is the thermodynamic stability and second one is the kinetic stability. Because stability is the stability word, it is having a vast area which cover so many things. But for a particular complex, we have to mention there are different basic 2 types of stability, either thermodynamic stability or either kinetic stability. Now let's check out what are the thermodynamic stability and what is meant by kinetic stability. Thermodynamic stability means this is measure of the extent to which the complex will form or will be transformed into another species within a particular under certain conditions. When the system has reached equilibrium, when we are concerned with this type of stability, means we deals with the metal ligand bond energies, stability constant, etc. Now what is meant by exactly thermodynamic stability? Suppose we are trying to form a complex. The A plus B, there is a formation of a C complex. If we are focusing on the quality of product C, the quality of complex C, and we are not bothered about the time span or the rate of reaction, then you are dealing with the thermodynamic stability. Means, in another way, it has been stated that it is a measure of extent to which the complex will form. Means the percentage of yield, means the percentage of product form is most important in thermodynamic stability. Let's move toward the chemical stability, then comparatively we study with both. This kinetic stability, it is referred with that of the speed. with which the transformation leading to the attainment of equilibrium will occur. When we are interested in kinetic stability, and this is primarily for complex ion in solution, we deal with rates and mechanism of chemical reaction such as substitution, isomerization, racemization and electron or group transfer reaction, as well as with the thermodynamic variable involved in the formation of intermediate species or activated complexes. In the kinetic sense, it is more proper to call the complex inert or labile complex rather than stable or unstable complexes. Means the complexes in which the ligand are rapidly replaced by other are called labile, or non-inert complex. Those complex in which the substitution occurs slowly are termed as the inert complex. So this is the basic concept of thermodynamic stability and the kinetic stability. I am going to explain by taking one example. Suppose you want to rush somewhere, you want to go somewhere and you have a two-wheeler. Now the way on which you are going, the road is not good enough. Now you are going slowly by considering your condition and your bike condition, your two-wheeler condition, and you take a time and you relaxedly go and you focus on the quality of the person and the vehicle which has been reached out to that particular point. So in this case, you are focusing on the stability of the product you get after reaching at that particular final stage of reaction. Means you are talking about the stability of that product which has been formed during the reaction. For example, we take a reaction. Suppose A plus B, there is a formation of C complex. Now when A reacts with B, you take a time, you give the reaction time. Suppose there is the 1 hour has been given to that reaction. So after 5 minutes some product has been formed, after 5 minutes some, at the 1 hour the maximum product has been formed. Now in this case you are focusing on the percentage yield. Means when you are talking about the thermodynamic stability, you are talking about the percentage yield, you are talking about the product stability. The reaction must be reached equilibrium with a particular extent at a particular under obviously certain conditions. So you are talking about, when you are talking about thermodynamic stability, you are talking about the bond energies, stability constant, stability of product, yield of product, etc. But suppose the same reaction, same condition has been occurred. Now you have a bike and you are in a very good condition. Now you want to reach that particular place, but you have a time limit that is 5 minutes. Now you are rushing and you are speed up your vehicle. So before you are taking a time, suppose in first condition you are taking a 15 minutes, now you take a 5 minute only to reach that. Is that the same condition of vehicle and your is remain? No. But in this case, the stability of product you are not discussing. You are focusing on the time span or the speed of reaction. Now suppose again the same reaction, that is A plus B, there is a formation of C. You are now, when you are considering a kinetic stability, means it is kinetics, means it is related with the speed. Now when kinetic stability has been considered, then the reactant has been get converted into the product, and in this case you are mainly concerned as a speed of reaction, not a yield or the percentage of product formed. You are just discussing the quickness of that reaction. Suppose, for example, one more example, if you want to prepare some food, if you having enough time, you take a precaution and you take it in a proper way you give a proper shape of that particular, suppose roti you are making, you give a proper shape, you you consider it as it has been cooked very well from all the sides. If you have a time, then there is no time limit, then you take a quality of product. You are focusing on the quality of product, you are not focusing on the time requirement, you are just focusing on the product percentage yield, quality of product, etc. But if you are in a rush, if you lack of time, then you are considering a kinetic, means at that point if you are only 2 minutes and you are just preparing a roti, then how it is possible to make a overall goal chapati and then properly cook it? You just sometime you are not, means at that point you are not giving a quality focus, you are giving a time focus. So in this case you are discussing about the kinetics of that reaction. So the basic concept is that when you are talking about the thermodynamic stability, it is related with the bond energy, stability constant, stability of product, yield of complex, etc. But when you are considering the kinetic stability, it is deals with that of the kinetic, that is speed of reaction. Now, when we are considering this thermodynamically stable or unstable, the reaction which is stable under thermodynamic condition is considered as a stable complex, and the complex which is not unstable under thermodynamic condition, that can be declared as a unstable complex. But in a kinetic stability, the stable and unstable complexes, this naming has been replaced by the labile and the inert complex. Means there is a just term has been changed. When we are talking about the thermodynamic stability, the complex either stable thermodynamically or unstable. But when we are talking about the kinetic stability, the kinetically stable or kinetically unstable, these terms are not considered. There are new words has been enriched, that is labile and inert complex. Now what is meant by labile complex and inert complex? Suppose this is the complex, this is metal, central metal atom, this is ligand, it is having a coordination number 6, means obviously it is a octahedral complex, and this is the incoming attacking ligand. Means when this attacking ligand attacks to the existing ligand, one ligand has been replaced by X. So this is a simple substitution reaction where the L is replaced by X. Now if L is rapidly replaced by X, if L is rapidly replaced by X, then this Ml6 complex is considered as the labile, or it is non-inert complex. If a simple way, if it is responding easily, then it is labile, means it is not inert, means it is non-inert complex. But if L is slowly, or not replaced by X, then it is known as the inert complex. Make it simple, if this is easy to replace with a high speed, then it is known as the labile or non-inert complex. If it is not replacing, if this complex is not ready to give substitution reaction, or the rate of substitution is very slow, then it is counted as the inert complex. So these are the two terms as a sense of kinetic stability has been discussed. So the final statement, when in a complex the replacement of ligand is rapidly takes place, then it is known as the labile or non-inert complex, or those complex in which the substitution occur very slowly or sometime not occurred, then are called as the inert complex. So This is all about the stability definition and different two types of stability, that is thermodynamic stability and kinetic stability. And in kinetic stability we are discussing about the labile and the inert complex. In the next lecture we will start with the stepwise formation of complex and stepwise formation constant and overall formation constant. Up till then, take care, be safe, stay safe. Thank you very much.